Welcome to another episode of ArXiv Preprint Server Daily, AI Frontiers, where the latest research in science and technology is brought to light. Today, the focus is on cutting-edge advancements in software engineering, drawn from 10 papers published on April 24, 2025, on the ArXiv Preprint Server platform. These works cover a wide range of topics, from data migration tools to cybersecurity and software ecosystems, and from testing methodologies to team dynamics. The goal here is to unpack these complex ideas in a way that remains accessible yet rich in technical detail for a curious, tech-savvy audience. Let's dive into the innovations shaping the future of software engineering. To set the stage, let's explore what software engineering entails as a field. It is a critical branch of computer science dedicated to the design, development, testing, and maintenance of software systems. Far beyond just writing code, it ensures that software is reliable, scalable, and user-friendly. Software engineering impacts nearly every aspect of modern life, powering the apps on your phone, the systems in healthcare and finance, and even the technology behind spacecraft. The papers under discussion today highlight the diverse challenges and innovative solutions within this domain, showcasing its vital role in bridging theoretical concepts with practical, real-world applications. One prominent theme emerging from these papers is software modernization, particularly the challenge of updating legacy systems. Many businesses depend on outdated technology, which can be cumbersome to maintain or upgrade. A notable contribution comes from Ramos Vidal and colleagues, who introduced the dummy framework to streamline data migration between different database structures, significantly reducing the effort required from developers. Additionally, Sridharan and team investigate the concept of aging debt in code, identifying maintenance burdens that accumulate over time. These efforts underscore the urgent need to modernize critical systems across industries. Another critical theme is security within software ecosystems, especially as supply chain attacks become more prevalent. These attacks target the foundational components of software, posing significant risks. Prasimus and colleagues provided detailed analysis of a backdoor injection in XCutils, a widely used Linux compression library, revealing how attackers exploit not just code but also trust and development processes. This highlights systemic vulnerabilities. Meanwhile, Zhang and team leverage artificial intelligence models to detect malicious software packages, offering a proactive approach to safeguarding software integrity. The third key theme combines testing and team dynamics, both essential for software reliability and project success. Testing ensures that software functions as intended, while effective collaboration drives innovation. Tu and colleagues enhance testing through artificial intelligence-driven concurrent execution, achieving better code coverage. On the collaboration front, Cesari and team demonstrate that psychological safety in open-source projects increases contributor retention. Similarly, Herman and colleagues model communication perceptions in development teams, offering insights to improve teamwork and project outcomes. Let's take a closer look at concurrent execution, a hybrid testing approach featured in some of these studies. This technique blends symbolic and concrete testing methods to explore various paths within a program's code. Imagine it as solving a puzzle, where different inputs are tested by predicting their outcomes. As utilized by Tu and team, concurrent execution excels at uncovering hidden bugs, particularly in programs handling structured data. While its strength lies in detecting vulnerabilities, a challenge remains in managing complex input generation, which calls for smarter, more adaptive tools. Turning to impactful discoveries, several findings stand out from these papers. Tu and colleagues achieved a remarkable 14.15% improvement in test coverage using their artificial intelligence-driven tool, uncovering 6 new vulnerabilities in widely used software. Prasimus and team revealed how supply chain attacks exploit trust and processes beyond mere code, as seen in the XCutils case. Cesari and colleagues confirmed that psychological safety significantly boosts retention in open-source communities. Lastly, Ramos Vidal and team reduced developer workload in data migration, easing the modernization of legacy systems. The methodologies behind these studies provide insight into how complex software engineering problems are tackled. Empirical user studies, such as those by Ramos Vidal and team, involve developers testing new tools to assess usability. Quantitative analysis of large datasets from open-source repositories helps uncover trends like software aging or community challenges. Integration of artificial intelligence, particularly large language models, automates tasks in testing and security. Additionally, Simulation and modeling, as used by Herman and colleagues, predict outcomes in team communication, showcasing a blend of data-driven and human-centric research approaches. Now, let's delve into a seminal paper by Ramos Vidal and colleagues, titled Seamless Data Migration Between Database Schemas with Dummy Framework. This work was selected for its innovative approach to addressing legacy system upgrades. Its objective is to simplify data migration between database schemas, a persistent challenge for developers. The method involved comparing a domain-specific language against traditional SQL scripting with 21 developers. Results showed a significant reduction in cognitive load and time spent on tasks, offering a practical tool for modernization. Future research could test this framework across larger, more diverse organizational settings. The second seminal paper, by Tu and colleagues, is titled Large Language Model-Driven Concolic Execution for Highly Structured Test Input Generation. Chosen for its groundbreaking use of artificial intelligence in testing, it introduces the Cottontail tool to enhance concolic execution. The objective was to improve input generation for structured data. Tested on 8 open-source libraries, Cottontail achieved a 14.15% increase in line coverage and uncovered 6 vulnerabilities, 4 of which have been patched. While impactful, challenges remain in addressing artificial intelligence inconsistencies and computational costs for broader adoption. The third seminal paper, by Przimis and colleagues, titled Wolves in the Repository, examines a supply chain attack on XCutils, a critical Linux library. Selected for exposing systemic risks in open-source software, its objective was to analyze how attackers exploited trust and development processes. Through forensic analysis of GitHub events and social engineering tactics, the study highlights that security must extend beyond code to include people and processes. This work calls for new defenses, potentially through automated detection of anomalous contributor behavior, to protect vital open-source ecosystems. Looking toward the future, several directions emerge for software engineering. Expanding domain-specific tools, like the DAMI framework, could address broader software challenges. Security must evolve, possibly through artificial intelligence, to detect systemic threats within development communities. Fostering psychological safety in teams remains crucial for sustaining innovation in open-source projects. Finally, tackling aging debt, where outdated code accumulates maintenance costs, will be essential to manage the growing complexity of software systems over time. In conclusion, today's exploration of software engineering frontiers reveals transformative advancements. Artificial intelligence is reshaping testing and security, as demonstrated by Tu and Zhang and their respective teams. Human factors, including trust, psychological safety, and workload reduction, are equally critical, as shown in studies by Cesari and Przimis and their colleagues. Modernization tools, like those from Ramos Vidal and team, pave the way for overcoming legacy challenges. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the ArXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening.